Welcome dear students. We are on the CEC Gurukul lecture and we are in the series of electronic circuit, and in the electronic circuit we have discussed many components which are used for development of the electronic gadgets. In today's lecture we discuss the one of the important which we use in our houses, also in industry or as well as in the institute. So what is the topic today is the electric generator that is commonly used device in I think in every domain that electric generator used in the electronics. So what is this electric generator? This electric generator is also called a dynamo, and any machine that converts the mechanical energy to electricity for transmission and distribution over the power lines to domestic, commercial and the industrial customers. So electric generator is a device which convert mechanical energy into the electricity, right, for the transmission and distribution over the line to the domestic, commercial and industrial customers can use this electric generator. Now generators are also produce the electrical power required for the automobile, aircraft, ships and the trains also. It means generator we use in everywhere in a daily life and in the many where. So generator also produce the electrical power that converts the mechanical energy into the electricity. Means we are using the mechanical energy and then output in the form of the electrical power, and that electrical power may be used in many devices like automobiles, aircraft, ships and trains. So the mechanical power for an electric generator is usually obtained from a rotating shaft and is equal to the shaft torque multiplied by the rotational or the angular velocity. Like mechanical power, that is mechanical power for an electric generator is usually obtained from a rotating shaft and is equal to the shaft torque. Means we are just getting a torque after multiple rotational after the multiple rotation. Means the mechanical power may come from a number of sources. From where we can get the mechanical power, like a hydraulic turbines at dams and the waterfalls, wind turbines, steam turbines using the steam produced with the heat from the combustion of the fossil fuels or from nuclear fission. Gas turbines is also used, burning gas directly used in the turbines. Gasoline and diesel engines are used to produce the mechanical energy, and that mechanical power convert into the electric power, and that electrical power we will get from the generator. So construction and the speed of the generator may vary considerably depending on the characteristics of the mechanical prime mover, that on the basis of its rotation and the basis of its speed of the generator, the output we will get accordingly. So nearly all generators used to supply electric power network generate alternating current, which reverses polarity at a fixed frequency, that may be usually 50 to 60 cycles or the double reversals in a per second. Since the number of the generators are connected into a power network, they must operate at a same frequency for simultaneous generation. So they are therefore known as a synchronous generators, because they are following the synchronous operation. Means they are being operated at the same frequency for a simultaneously generation. That's why they are called the synchronous generator, or sometimes it is called the context or alternators. So electric generators were discovered even before the discovery of the connection between the electricity and the magnetism. Means moving electrically charged plates, disc and the plates were used to operate the electric generator. Means we in the electric generator we are using the rotating plates that produce the electric current. and it follows the electrostatic principle. The electric generator follow the electrostatic principle. The charge was mainly produced by using either of two mechanisms. First is the turboelectric effect and second is the electrostatic induction of the turboelectric effect. Means here the electric generator was discovered even before the discovery of the connection of the electricity and magnetism. Before that the electric generator came into the account, but here we are using just to get the electric output through the generator, we use the rotating plates, and the principle behind the generator is the electrostatic principle, and the charge was mainly produced by using the two mechanisms. First is turboelectric effect and second the electrostatic induction. Such kind of generators produce low current and high voltage. Generators are very useful as it supplies power to the electric appliances or during a power distribution. So generators are available in various physical and electrical configuration for use in the different applications. So what is the history behind the electric generator? Electric generator were used before the relationship between the electricity and magnetism that I discussed. The generator operated on the electrostatic principle. Electrostatic generator were never used for generation of the commercial significant quantities of electric power due to the following reason. Number one, it is due to the difficulty in the insulating mechanism that produces high voltage. Due to the low power rating, due to the high inefficiency of the electrostatic generators, the first electromagnetic generator was the Faraday disc was invented in 1831. That was not for the commercial use, but the British scientist Faraday. The first generator was discovered. After how do generators create electricity? So what are the steps how we can get the electricity through the generator, as it converts the mechanical energy into the electrical energy, mechanical power to the electrical power. So generator do not create electricity, instead it uses the mechanical supplied to it to the force movement of the electric charges present in the wire of its windings through the external electric circuits. So the flow of electrons constitute the output electric current supplied by the generator. In the modern days, work on the principle of the electromagnetic induction that was discovered by the Faraday. He realized that the above flow of the current can be created by moving an electrical conductor in the magnetic field. It means we use the magnetic field. After discovery of the magnetic field, relation between the electricity and magnetism, then the Faraday realized that the flow of current can be created by moving an electric conductor in a magnetic field. Means we produce a magnetic field around the electric conductor, and that produces the flow of current. This movement creates a voltage difference between the two ends of the conductor, which causes the electric charges to flow, hence generating the electric current. So what are the steps, what are the principle of the electromagnetic induction that was given by the Faraday? What happened? The flow of current can be created by moving an electrical conductor in a magnetic field, and that movement creates a voltage difference between the ends of the conductor, and which produces the electric charges to flow, and hence the electric current generated. So these are the steps to get the electric current through the electric generator. What are the components we use in the electric generator? The main components of an electric generator, first is a frame, that is the structure in which we just keep this generator. Second, an engine, the source of mechanical energy, that mechanical energy which converted into the electrical form. So the first is the frame, the structure in which we put it. Second is the engine, that is the source of mechanical energy. Third is the alternator that produces the electrical output from the mechanical input, that is the alternator. A fuel system to keep the generator operational, means we use the fuel system, and a voltage regulator to regulate the voltage output. And another components are a cooling system, as the heat generated regularly, so to regulate the heat levels that build up in the system. Next is a lubrication system for durable and the smooth operation over a span, that's why we use the lubrication system. An exhaust system to dispose of the waste exhaust gases produced in the process. Next is the charger, that to keep the battery of the generator charged. Next is the main control, that is the main unit to control the panel, controlling the generator interface. These are the basic components we use in the electric generator. First is the frame, engine, alternator, fuel system, voltage regulator, cooling system, lubrication system, exhaust system, charger, and the main control. Now you see on the screen here, we see that the rotator is in between the magnetic field. North and south pole you are seeing, NNS are the magnetic field which is giving to the system. That is a coil rotating by the mechanical means. This coil, and this coil contain the carbon brush, and this carbon brush, both the side we are having a carbon brush, and the path of the motion at this mechanical energy given to, and that mechanical energy in between that and the system is in between the in between the magnetic field, and the electricity will generate. This is the schematic diagram of the generator. So what are the types of the generator? Here we define the classification of the electrical generator depends on the type of electrical energy that it produced, which is either direct current or the alternating current. So on the basis of the output, that it depends upon the classification. First is the AC generator. AC generator are known as a single phase generator and are limited to 25 kilowatt. And second is the DC generator. These generators are divided into three categories, and they are shunt, series, and the compound wound. So shunt generators are used in the battery charges, series generators are used in the street lights, while the most of the DC generators are the compound wound. So AC generator and the DC generator, AC generator are the single phase generator, while the DC as are three categories: shunt, series, and compound. Shunt used for the battery, series for the street lights, and compound generally we use the compound wound. What are the uses of the electric generator? They provide the power for the most power network across the sites. As we are getting the electric power, so small scale generators provide a good backup for the household power needs or the small businesses. At construction site, we can use the power setup. They extensively make use of the electric generator, and energy efficient as a fuel consumption is reduced drastically if we use the electric generator, and they give a range of the voltage output, and they are used in the various labs, and they are used in the drive motors, used in the transportations. What are the difference between the motor and the generator? In the last time we discussed about the motor, and this time we are discussing about the generator. First we discuss what is the difference between the motor and the generator. The main difference between the electric motor and generator, that the generator, as we are having that their functions, structure, and other related details we discuss. So there are the two electric motors and electric, you see on the screen that this right hand side you are seeing the generator, and left hand side it is a motor. What is the difference? First is an electric motor is a machine that converts the electrical energy to the mechanical energy, while the generator that converts the mechanical energy into the electrical energy. And what are the difference? What is the rule? Electric motors follows the Fleming's left hand rule, while the electric generator follows the Fleming's right hand rule. Another difference is the principle. The working principle of the motor is based upon the current carrying conductor that experiences a force when it is kept in the magnetic field, while in the generator the working principle generator is based upon the electromagnetic induction. So, this is the difference between the principle of the motors and generator. The fourth difference is the driving force for the shaft. The shaft of an electric motor is driven by a magnetic force which is developed between the armature and the field, while in the generator the shaft on an electric generator is connected to the rotor, which is driven by the mechanical force. And this is the difference between the driving force. Current uses is the motor current is supplied to the armature winding, but here in the generator current is produced in the armature winding. And examples, the motors are used in ceiling fans, cars, etc., and all examples of the motors, while the power generators are used generating the electricity, and it are used in many appliances. Now we are discussing the various basic classification of the generator. So in the first we discuss the AC generator. What is the AC generator? From the flipping a switch to heating a snack in the microwave. Electricity is everywhere. Now that we can thought about it, and we can might wonder how it essentially energy sources is generated and how it arrives at the doorstep. So AC generator that produce the electricity. Electricity is produced in the power solutions using the turbines and the generators. So turbine converts the available energy into the rotational, while the electric generators convert the rotational into the electricity. Means turbine converts the available energy into the rotation, while the electric generators convert the rotational into the electricity. Based on the electric output, generator are classified into AC or the DC generator. The AC generator that produce the AC output, and DC that produce the DC output. So AC generator plays a crucial role in the power generation, because they can produce the electricity at the described as the desired output. So AC generator produce the electricity at a desired voltage and the desired frequency, which can easily be adjusted by the various application. It means when we require the certain output or certain output in the form of the voltage and frequency, then we use the AC, and they are mostly used in the power plants, where the mechanical energy from the source like steam turbine or the water turbine is used to turn the generator's armature and produce the electrical power in the form of the alternating current. The alternating current can be generated and that transformed and transmitted to the various places like homes, businesses, industrial, for the various electrical needs. So AC that are used in the power plants that converts the mechanical energy from the various source to the electrical energy and pass the required places. So AC generator is a machine that converts the mechanical energy into the electrical energy, and the AC generator's input supply is the mechanical energy supplied by the steam turbines, gas turbines, consumption engines, and output is alternating electric power in the form of the alternating voltage and the current. And this AC generator works on the principle of Faraday's law of the electromagnetic induction, which states that the electromotive force, that is EMF, or we can call it as a voltage, is generated in a current carrying conductor that cuts a uniform magnetic field. that is a Faraday law of electromagnetic induction. Means electromagnetic force is EMF or the voltage is generated in a current carrying conductor that cuts a uniform magnetic field, and this can either be achieved by rotating a conducting coil in a static magnetic field or rotating the magnetic field containing the stationary conductors. So both is possible, either rotating the conducting coil or keep the conductor stationary, rotating the magnetic field. The two steps we can follow: is conducting coil is rotating in the static magnetic field, or we can do in the second step, we can do rotating the magnetic field containing the stationary conductor. So both we can prefer. So the preferred arrangement is to keep the coil stationary because it is easier to draw the induced alternating current from a stationary armature coil that from a rotating coil. So you see on the screen here that we keep the Sn constant and then we rotate the rotor. Here we use you see on the screen that is a rotor, and there is a slip rings and brush are used here, and you see that the stator is there, rotator, stator, field stationary. As you see, the magnetic field is stationary here, but the conductor is rotating. So now this is the schematic diagram. So how the AC generator works? So now we can see that AC can be created by rotating the coil of the wire between the poles of the permanent magnet, as we have seen in the diagram. The coil is known as the armature and the slip rings are connected to the ends of the armature and they are insulated from the armature and from each other. Armature we can use just to connect in the permanent magnetic field. We use the brushes. That brushes which is present will press against the slip rings and it would make it possible to connect an external circuit to the rotating armature. So you see on the screen here that here Ns is fixed and this coil, conducting coil, is rotating through the shaft, and you see here a simple one coil AC generator here on the screen. So the various part of the AC generator are field, armature, prime mover, rotor, stator and slip rings. So AC generator is also known as the alternator, which consists of the several key parts and components that work together into the electric energy generation and in the form of the alternating current, and these parts we can discuss in the next lecture one by one. Thank you very much.